Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Al-Zamani. My metric number is AE190027. So I will present for the activity 1. Okay, for the first one, this is the simulation, circuit simulation for activity 1. Okay, we need to set parameter input and angle attenuator gain is equal to 1. Okay, I set input angle 1, attenuator gain 1, and then I get the shaft motor position 11.73 and input voltage 0.61111. Okay, next we need to increase step by step of input angle from 0 until 10 and set the attenuator gain 0, and then we need to observe the shaft motor position display and what happened to the system. Okay, for input angle 0, okay, input angle 0, and then for the input voltage we get 0 and the shaft position also 0. For the input angle 1, input voltage I get 0.6111 and the shaft motor position is 0. For the input angle 2, for the input angle 2, for the input voltage I get 1.2222 and shaft motor position 0. For the input angle 3, for the input voltage I get 1.833 and the shaft position motor 0. For the input angle equal to 4, for the input voltage I get 2.444 and the shaft motor position we get 0. For the input angle 5, the input voltage for input angle 5 is 3.066 and shaft motor position 0. For the input angle 6, input voltage I get 3.667 and shaft motor position 0, still 0. For input angle 7, input voltage I get 4.278 and shaft motor position 0. For the input angle 8, input voltage I get 4.889 and shaft motor position 0. For input angle 9, input voltage I get 5.5 and shaft motor position 0. For input angle 10, I get 6.111 and shaft motor position is 0 also. We need to increase step by step value of attenuator gain from 0 until 10, this attenuator gain, and set input angle to 0 and observe the shaft motor position display and what happened to the system. Okay, for the attenuator gain 0, we get the input voltage 0 and shaft position motor 0. I think for the attenuator, if we change the attenuator value, we'll also get the 0 for the shaft motor position and the input voltage. Okay, let's see this one. Phase 3, attenuator gain 3, input voltage and shaft motor position 0. 4 also, still they get the same answer. Okay, from the input angle 0 until 10 and attenuator value is 0. Okay, for the discussion is from the picture shown, we know that input voltage will increase along with the value of input angle increment. This is because the value obtained from the result input angle value multiplied with the potentiometer gain value. Okay, discussion from the attenuator gain value 0 until 10, input angle equal to 0. Okay, the display value for the shaft motor position is 0 for 0 until 10. The display value for shaft motor position is 0 for 0 until 10 of attenuator gain. This is because the input angle is set of 0. Okay. Table 1, open loop position control response. Input potentiometer direction, input angle power position, attenuator gain, input voltage and shaft motor position. Okay, for the clockwise, input angle we get 5, attenuator gain 1, input voltage 3.056, shaft motor position 58.464. Okay, for the anti-clockwise, still get the same value but negative at the in front of the value, negative 5, negative 3.056, negative 58.64. Okay, this is the table. Okay, for the average error percentage, error of 5%, we get 91.47%. Error for 10%, we get 98.29%. And error for 360%, we get 98.93%. Okay, that's all from me. Thank you.
Assalamualaikum and very good day to Doctor. My name is Muhammad Amir Ridwan bin Muhammad Ghazali, metric number AE100036. So I will explain about how do we do the simulation for activity number 2. Okay, for activity 2, the first step that we need to do is, so the first thing is to check whether the block diagram function or not. So we key in the input angle value is 1 and the attenuator gain value is 1. So basically this is I already insert the value of 1 for the input angle and attenuator gain. So we run for the simulation to check the block function. Okay, so basically the display shows the value. That means the function block is in a good function. So therefore we move to step number 4, which is to increase step by step value of input angle from 0 till 10 and set the attenuator gain to 0. So now we set this attenuator gain from 1 to 0. Okay, so now the attenuator gain is 0 and the input value angle is 1. So now we run the simulation to check output angle and the system. So basically the input angle shows the 0 value. So now we change the value of 1 from 1 to 2 to check the system. So we run the simulation again. Okay, so basically the system shows that the output angle is 0. So now we just need to repeat the same step, which is to change the value of 2 to 3, 4, 5, 6, 7 till 10. And then we just need to investigate how the system works. So now for the step number 5, we need to increase step by step value of attenuator gain from 0 till 10 and the input angle is set to 0. So now we change the value of input angle from, so we just need to put 0. Then for the attenuator gain we change to 1. And then we run the simulation. Okay, so basically for the output position, we also get the 0 value, and therefore we change the value of attenuator gain to 2. Need to run the simulation again to investigate the system. Okay, so now here we have the result, which is also the 0 value showing for the output position. So now for the next step, we just need to change the value of 1, which is to increase step by step from 2 to 10. And then investigate the output position value and how the system acts. And now for the step number 6, we just need to set the input angle to 5, 150 and 360 for the clockwise and anti-clockwise. So basically for the input angle of 5, we need to set the attenuator gain to 1. So now for the first case, we need to set the attenuator gain to 1. the input angle is, so the first case for input angle is 5 in clockwise, which is 5. So we run the simulation to check the value of output angle. Okay, so basically this is the value of output angle position, and this is the value of input voltage, and this is the value for output voltage. So these three value we just need to record in table 3.2. So now we change the value of 5 to -5, which is for the anti-clockwise. We run the simulation again. Okay, so now we get the value of anti-clockwise input angle. So basically we just need to repeat the same step, which is to record this value into table 3.3. So now for the next step is that we need to change the value of attenuator gain from 1 to 5 for the input angle of 150 for clockwise and anti-clockwise. So then we just need to repeat the same step, run the simulation and record this three value into table 3.3 for the respective value of input angle, which is the 150 for clockwise and anti-clockwise, and 360 for clockwise and anti-clockwise, which is the attenuator gain is 8. So that's all for activity number 2.